Can you
Okay.
see, either you tell me the question or I will just go through the. Wait a minute. Okay, yeah. Okay, wait, I will just run it over here itself. Okay, here it is. Hanji, can you tell me the page number?
Page number 52.
Okay, huh. Which question?
12.
Which exercise?
3.3.
This one. Okay, found it. Okay, fine. So this is 3.3 health question. Huh, what about it?
I didn't understand.
You didn't understand? Okay. We did the entire chapter, no? Wait, let me just check whether we've done the entire chapter or not. Yeah, see, this is the question. So the question says, if the measure of angle, find the measure of angle P and angle S, which is written over here, find the measure of angle P and angle S. If SP is parallel to RQ. SP is parallel to RQ. These two red things are parallel to each other. So find this. So they are telling us that in this, see, clearly this is 90 degrees, right? This is 90 degrees. So let me just
Wait, I understood.
Understood.
Yeah.
Tell me, what did you understand?
I was just confused at how S and R are supplementary.
They are supplementary because they are co-interior angles. If you consider this as the transversal, then they are co-interior angles.
All right.
Okay. And then similarly,
but how do we know? But the transversal is always, like it's not straight.
Who said it's not straight? Is it a condition for a transversal that it can't be straight? If you have any two lines, these two lines also don't need to be parallel. They can be anything. There are two lines and a third line is cutting them. It can cut them at an angle. It can cut them at 90 degrees. It can cut them at anything. It doesn't have to be slanting. They just show it to you slanting because it can be slanting also. Otherwise, if they show it to you like this, then you'll think that a slanting line cannot be transversal. Then you will think it like that. That is why they show it slanting. This angle can be anything. Okay.
All right. Okay.
Acha, so this is clear then. Next doubt.
Then exercise 3.3, the last question.
3.3, last question. This one only, no? This is the 12th question, the last question.
No, sorry, 3.4.
3.4. Last question, huh? What about that question?
I also didn't understand this.
Didn't understand it. Okay. There it is. Read the question.
ABC is a right angle triangle and O is the midpoint of the side opposite to the right angle. Explain why 0 is equidistant from A, B, and C. The dotted lines are drawn additionally to help you.
So, what are they saying? They are saying that O is the midpoint of the side opposite to the right angle. So, the side opposite to the right angle, which is this. This is the right angle. Yeah.
Yeah.
In this triangle, in the ABC, in triangle ABC, in this triangle, angle B is the right angle, right? So the side opposite to the right angle is AC. And they are saying that O is the midpoint. So explain why O is equidistant from A, B, and C. So they are telling you that AO is equal to OC. This is already given. Okay, now you have to tell why is O equidistant. Equidistant means, for example, for example, if I, this is your, let's say this is your home and this is your school. Okay, and this is, let's say, the mall. Fine. If I say that the mall is equidistant from your home and school, that means the distance between your home and the mall is the same as the distance between the school and the mall. So what does this mean? The distance MH is equal to the distance MS. This is what it means. Okay. So they are saying that you have to show that O is equidistant from A, B, and C, meaning you have to show that OA is equal to OB is equal to, what is the third point? And C, so
OC.
OC. So, so OA is equal to OC is already given to us in the question. How is it given? They are telling you that it is the midpoint,
Yeah.
right? So this part is already given. We just need to show that OA is equal to OB. Okay. Till here,
Okay.
did you understand?
Yes.
Okay, just a minute ago. Just a minute. Just a second. Okay. So, now we have to show that AO is equal to, matlab we have to show that the rest of them, they are equal to OB also. Okay. So now what we have done here is, we have said that, well, BD and AC, they are diagonals of the rectangle, and we know that diagonals of a rectangle are equal. Yeah.
Yeah.
So that is why BD is going to be equal to AC. So if BD is equal to AC, then now we know that what is AC? AC is basically AO plus OC, right? AC, I'm going to write it here, is equal to AO plus OC. Yeah.
Yeah.
And AO and OC are both equal because O is the midpoint. Now what we've done is, we have said that if AC is equal to BD, then that means half of AC should be equal to half of BD.
Yes.
So since BD is equal to AC, so we can say that half of BD will be equal to half of AC. Now what is half of AC? Half of AC is nothing but your AO. Okay.
Okay.
Half of AC is AO, because again O is the midpoint. That is why AO is, or OC, you can say AO also, you can say OC also. They are both half of AC. So that is why what we have done here is, we have said that this is equal to half of AC is equal to half of BD. So half of AC is this thing, AO and OC. And half of BD, as you can see from the figure, it is BO. So that is why they are all equal to each other.
All right, understood.
Okay. And this thing we got, why did we write this as, why did we write half of BD as BO? Because we know that diagonals of a rectangle bisect each other. This is a rectangle, right? So the diagonals are going to bisect each other, meaning that BO is going to be equal to OD. Meaning that BD, this diagonal BD is being bisected, meaning that BO is going to be equal to BD, meaning BO is going to be half of BD. Sorry, BO is going to be equal to OD, so BO is equal to half of BD. Okay?
Okay.
Is this clear?
Yes.
Any other question?
Not from this chapter.
Okay, tell me which chapter.
Can you give me a minute? I have to find it. Yeah, I have no doubts.
No other doubts? Then what are we going to discuss in today's class? Should I take a test?
Yeah.
Okay, fine. Let's have a test. Now wait a minute. I will give you a few questions from each chapter. Okay.
Okay.
Uh, okay. Let's start with the chapter which we have just recently done. Are you writing the question?
Yes.
Write down the question. and keep solving them simultaneously because it will take me a while to search for the questions.
Or can we like there's this worksheet, like it's prepared by our school for this examination. Can we do that?
Yeah, that will be better. Have you solved
All
it
right.
yet?
No, I'll send it to you on WhatsApp.
Oh, okay. Hiba, the worksheet sent by your school, you're supposed to solve that first. Send it.
Uh,
Send.
I completed some questions
Okay.
of the
So did
worksheet.
you complete them? Like, were you able to solve them?
Yeah.
ठीक है. So you tell me which questions you were not able to solve. Acha, you have sent. Okay. Fine. Which question then?
We can just like do it like each question.
Okay.
So the first question, zero is the additive identity, and one is the multiplicative identity.
Good. Then
The reciprocal for any rational number pq, where p and q are integers and q is equal to zero, is
non-zero. Q is
zero.
non-zero, बच्चे. Q is
Oh
not
yeah,
equal to
sorry.
zero. Hmm.
Is zero.
Reciprocal is zero.
No, sorry.
Bachche,
Q by p.
what are they asking? Then third one.
Uh, the additive inverse of minus, it will be 3 by minus 8.
No, 3 by 8.
Oh yeah, sorry, 3 by 8.
Then
Divided by 11 by 7. No, minus 11 by 7.
minus 11 by 7. Are you? अच्छा हाँ ठीक है minus 11 by 7. Okay. Then
0 has no reciprocal.
very good. Then
Minus 1 and 1 are the multiplicative inverse of themselves itself.
minus 1 and 1. Okay, good. Then
For all rational numbers a, b, c, a, b plus c is equal to ab plus ac.
very good. The D option. Then 8th one.
1. I think.
Is the only rational number which is equal to its no.
0.
What is the additive inverse of? Yes, 0. Then, acha,
But how
I
is it?
missed. Continue. Bache, what is the additive inverse of 1?
1 is 1 itself.
Additive inverse. Additive, not
Sorry, minus
multiplicative.
1.
-1. Bache, so 1 ka additive inverse is -1 because 1 minus 1 is 0, right? They are asking you what is the number whose additive inverse is the number itself. Meaning, okay, to get additive inverse, what do you need to have over here? It's supposed to be the additive identity, which is 0, right? So which number added to itself will give you 0? See, 1 plus 1 will never be 0. -1 plus -1 will never be 0. Then what is the number which when added to itself gives you the additive identity, which is 0?
0.
0. So the answer will be 0. Got it?
Okay.
Next.
The numerical expression 3 by 8 plus -5 by 7 gives -19 by 56 shows that rational number are closed under addition.
Are closed under addition. Yes, very good.
I didn't understand this question though.
But closed means closure property. Closure property means, for example, if you take two, what closure property says is that if you take two rational numbers and you add them, you will always get a rational number, right? Or are you going to get something else, which is not a rational number? It will always be a rational number. Similarly,
Yeah.
if you subtract two of them, the answer will always be a rational number p by q, right? So it will always be a rational number. Similarly, if you multiply them, it will always be a rational number. Yes. So closure property holds under addition, under subtraction, under multiplication. But under division, does it hold closure property? No. Why?
No.
Why?
Because the answer will be 0.
No, answer will not be 0. Because if you divide any number by 0, the answer
Yeah,
is not
sorry.
defined in rational numbers. The answer will be not defined. So that is why they are not closed. Rational numbers are not closed under division. They are closed under everything else. Closed means that operation you are doing, whether it is plus, minus, into, divide. When you're doing that operation, that answer should be within rational numbers itself.
All right.
Then next.
The multiplicative inverse of 7 by -3 is 3 by 7.
Multiplicative inverse is not 3 by 7. It is -3 by 7.
Oh yeah, sorry. Wait, what's the difference between the third question and the 10th question?
But in the third question, they are asking additive inverse. In the 10th question, they are asking multiplicative inverse. So in the third question, just imagine yourself adding 3 by 8. What are you doing? Additive inverse, no? So you have to add it. -3 by 8 plus its additive inverse, which is 3 by 8. When you add it, you will get 0. So we are supposed to get the additive identity when we are adding. And we are supposed to get the multiplicative identity when we are multiplying. So multiplicative inverse will be -3 by 7. Why? Because -3 will get cancelled, 7 will get cancelled. You will be left with 1. The answer will be 1, which is what you are supposed to get. Did you get it?
Yeah.
Okay, then next.
There are infinite rational numbers between any two rational numbers. The the product of a rational number and its multiplicative inverse is always 1.
1. Very good. Then
Identify the property shown in the following. The first one is multiplicative identity.
very good. Then
The second one is multiplicative inverse.
very good.
The third one is associative property.
But it's not associative. It is,
So
see,
it's
associative comes into
closure.
play. Commutative, bache. This is commutative. Because what they are doing here is, this is one number which now they are, it's like, it's basically saying this is A into B and this is B into A. So A into B is equal to B into A. This
Oh,
is
yeah,
the commutative property. Associative property comes when there are 3 numbers involved. Then fourth one is?
Fourth one is that associative. No. It's distributive. Or property
Distributive,
of,
yes.
yeah.
Distributive.
And the last one is associative.
Last one is associative. Okay, good.
Then find that. I find it.
This is a pretty lengthy thing, and we have only half an hour remaining. So you can do this now?
Yeah.
Pakka.
Yes.
Okay. Next, second question.
Wait a second. How are we supposed to do the 14th question? We
The
just
14th question. This one.
yeah.
See, here you don't do this and this first. Okay, instead of doing this and this first solve these two because they have same denominators. So first solve these two. So 3 by 7 as it is. Just a minute. So 3 by 7 as it is. Then this becomes minus 6 by 11 minus 8 by 11 plus 5 by 22. Which property have we used here? We have used here associative property. Associative property basically tells us that we can put a bracket over here. First, instead of first solving this, instead of going in order, first we will solve this, then this, then this. Instead of that, we can first solve these two, and then we can solve the rest. That is what associative property says. So now we are doing this minus 6 minus 18 minus 8 is minus 14 by 11. So this is 3 by 7 plus minus 14 by 11 plus 5 by 22. Now we can solve all three of them together if you want. We can solve these two
find the
first if you
LCM,
want.
right?
Yeah, we can find the LCM. So
like
the LCM
if we find the answer for minus 14 by 11 plus 5 by 22, and whatever answers come, we have to find the LCM of it with 7.
Yeah.
Okay, then I can do this.
So you can multiply this with 2 upar and niche. So this will become minus 28 by 11. Oh, sorry, 22. Minus 28 by 22. And this is plus 5 by 22. So this entire thing becomes minus 23 by 22. So 3 by 7 minus 23 by 22. So when you find the LCM of these two things, it will actually be 154. So 7 into 22, so this will be 66 minus 151. So just solve it and you will get the answer, okay?
Okay.
All right. This one also, so now this one, what you can do is, this is very simple, okay? Just remember that
We can solve the bracket one first.
Not necessarily. You can just remove the bracket also. And you can just do it like this. See, the ones on the, this is the first floor, this is the ground floor. Okay. The ones on the first floor will always cancel the ones on the ground floor. Doesn't matter if they are on top of each, one is on top of the other or not. So for example, this 7 can cancel this 14. So it will become -2.
-2.
Okay. This 3
And
will
then,
cancel this 9. It will become 3. This 5
yeah,
will cancel this 15. 5 threes are 15. 3 ones are 3. Right? Then 4
and then
fours are
16.
very good. 4 fours are, this is -1 by the way. Don't forget the minus sign. Okay. And then 2 twos are 4. So this is again -1. So what are we left with? We have -1 into -1 divided by 2. So that is -1 into -1 divided by 2. 1 into 1 is 1. And negative multiplied by negative is positive. So it is positive 1 by 2.
Wait, I have a question. When we
Yeah.
cancelled 5 and 15, why didn't we write 1 there, like below 5?
Okay, no problem. You can write 5 ones are 5, 5. See, Hiba, you can write it, but you can also skip it because 1 is you. It's just 1, na? 1 multiplied by anything is going to be the same thing. So when we do cancellation, we often skip the 1. It's okay. You can write the 1. You can skip it
So why did we write -1 for -4?
because there's a minus sign over here, na? If you don't
So
write the
wouldn't
minus, hmm,
so wouldn't +1 change the signs if we like used it?
which see, but positive never changes the sign of anything. Positive is always positive. It is the negative one which is notorious, which changes the signs of other numbers. So if I have if I have a positive number over here, and if I multiply it with a negative sign, the negative sign will change the sign of this number inside the bracket. But a positive sign never changes the sign of anything. Positive never changes the sign of anything. Negative is the one that changes the sign of other numbers. Okay. So this
Okay, I
positive
understood.
one is going to do no one any harm. It's not going to do any harm to anyone. That is why we can skip it or we can write it. It's up to us. Okay.
Okay.
Hmm. Done.
Yes.
Next question.
Yeah.
Next.
Okay.
Which?
The solution of 2x minus 5 is equal to 10 is, we will bring 5 to the other side.
Hmm.
So 15, and
Okay.
it
2x
will
is
become
equal to
15.
15.
Yeah, and then we will bring 2 to the other side, and then
What will it become?
15, we can't cancel it.
Just 15 by 2. Write 15 by 2.
Oh, yeah, yeah.
Okay.
Okay.
Then a linear equation in one variable has.
In one variable has only one solution.
Yes, only one solution. Which of the following is a linear expression?
Wait, can you explain the second question?
Acha. A linear equation in one variable. See, solution means what is the solution over here? The solution is 15 by 2. Hai na? Linear equation in one variable.
Yeah.
What is a linear equation in one variable? Can you tell me?
Like it has one variable.
Yeah, a linear equation. First of all, linear means there should not be degree 2. It should not be x square or x cube or anything. Only x. Only x matters. Okay. Meaning in the sense
Okay.
that x square will be a problem if you're talking about linear equation. X cube will be a problem. But if it is 5 cube, then it is not a problem. 5 square, not a problem. 10 cube, not a problem. Only x only x matters over here in the sense that linear means the power of x, power of variable should be 1. Over here it's x to the power 1, right?
Yeah.
So it is power of variable is 1. Power of other things can be anything. 5 square, 10 cube, whatever. But the power of the variable should be 1. That is what linear means. That is the meaning of linear. Now, what is the meaning of equation? Equation means some expression which has an equal to sign in it. Okay. That is the meaning of equation in one variable. Meaning that, for example, let me show you an example. Okay, it's not here. So, for example, if you have x plus y is equal to 5, this is linear, yes, because the variable power is 1, right? X to the power 1, y to the power 1. But this is not in one variable because there are two variables x and y. So this is not one variable thing. A one variable linear equation means it is going to be just x or just whatever the variable is. For example, over here it is t, so it will be t throughout, and the power of t will be 1, meaning it will not be t square, t cube, nothing. Just t, plain t. Okay. X, x. Okay. So this is linear equation in one variable. Now they're saying the solution, it, it has how many solutions? As you can see, when you solve this equation, you will get only one value of x. Now, you can, if I
Yeah.
give you, for example, if I give you x minus 3 is equal to 4, then you will get only one value of x. X is equal to 4 plus 3 is equal to 7. That's it. Straightforward 7. It will not have more than one solution. See, the reason why they ask you this question is because in ninth grade, you are going to study linear equations in two variables. Okay. So over there, they have two variables. Here you have one variable, x. Over there, they have two variables. So in that case, the number of solutions of that equation becomes more than one. That is why it is important for us to know that when there is just one variable, there will be only one solution. Okay.
Okay.
Only one solution. Then which of the following is a linear expression?
The last one. The last option.
Last one is a linear expression. Then fourth,
If x is equal to 1 by 2, then 5 by 4 minus x by 2 is
what you have to do is just put 1 by 2 in place of x. So what does this become? In place of x, you have to put 1 by 2. So see, this is 5 by 4. This is 5 by 4 minus x by 2, right? X by 2 means what? You can write x by 2 as 1 by 2 into x, yes or no? This is x by 2
how?
or not? Hiba, this is something you know very well. 5 by 4 can be written as 5 into 1 by 4 or not?
Yeah.
Huh? So similarly, 2 by 3 can be written as 1 by 3 into 2.
Yes.
Because when you multiply the numerators, it becomes what? Again, it gives you 2 by 3 only. Na? When you multiply these two, 1 into 2 is 2. And in the denominator, you have 3. So you can write x by 2 as 1 by 2 into x. Yes.
Yes.
Now they're telling you the value of x is 1 by 2. It is half. So in place of x, you just put what? 1 by 2. In place of x, you have to just put 1 by 2. Okay. Or if you don't
Oh.
want to put a bracket, just write it like this. 1 by 2. So what have we done in place of x? Here we had x. In place of x, we put 1 by 2. So now this becomes what? 5 by 4 is as it is. 5 by
But
4
why did we
Hmm.
write 1 by 2 first?
Why did we write it as 1 by 2 into x?
Yeah.
Hiba, because you can do it without writing it like that also. It is 5 by 4 minus x by 2, na? So here you have to put 1 by 2. So this is a fraction of a fraction. Getting it? So you will get
Yeah.
confused in this. That is why I told you the easy way. Got it?
So like if I write like this, how do we solve it?
If you want to write it like this, 1 by 2 by 2. Remember, denominator. So this is basically, this 1 by 2 can be written as, this 1 by 2 can be written as 1 by 2 over here. And since there is nothing over here, you can just write 1. Okay. This
Okay.
1 by, let me give you another example. If it is something like 1 by 3 by 5, this is nothing but 1 by 3, and this is also the denominator,
Into,
and 5 is also denominator. So 1 by 3 into 1 by 5.
all right.
Or
So we can write 5 by 4 minus 1 by 2 minus multiplied by 1 by 2.
1 by 2 into 1 by 2. So this becomes 1 by 2 into 1 by 2 is how much?
Oh, 1 by 2.
Huh? Bache, when we
I
are
mean 1 by 4.
multiplying, we multiply the numerator with numerator and denominator with denominator. So this becomes 1 by 4. So 5 by 4 minus 1 by 4 is how much? 1 by 4. Sorry.
1 by 4.
4 by 4, which is 1. 4 by
1.
4 is nothing but 1. Yes.
Okay, understood.
Next.
Wait a second. Solve the following equations.
Okay, let's do one thing. Out of these, you tell me which one you want to solve, because
The 8th one.
8th one. Achha, this one. Fine. So let's do one thing. So this is what? 1 by 2 into x plus 1, 1 by 3 into x minus 1, 5 by 12 into x minus 2. Now let's, in such a case, what we can do is bring all the x's, all the x terms to one side. Okay. Or if you don't want to do that, I'll just tell you the shortcut, okay? Because Hiba, you are good at remembering shortcuts. That is one thing I know about you. So just remember the shortcut, and that is, when you have such a case now, multiply the entire equation by the LCM of all of the denominators. Okay. LCM of all the denominators. So what is the LCM of 2, 3, and 12? See, when you multiply 2 and 3, you get 6. And the LCM of 2 and the LCM of 6 and 12 is 12. So if you want, you can solve this. Try finding the LCM of these two. It will turn out to be 12. But
12.
I was just telling you that it is going to be 12. You found it?
Yeah, it's 12.
So multiply the entire equation, meaning multiply every single term with 12. And we can do that, right? We know that in an equation, if there's an equal to sign, there is something on the left hand side, something on the right hand side. We can multiply both of them with the same number. Both the sides of the equation we can multiply by the same number, or we can add by the same number.
So how do we multiply it?
We can, what we need to do here is we have to multiply 12 na? So in each term, just multiply each term by 12. So it's going to become 12 into this plus 12 into this plus 12 into this. Okay. And why are we doing this? We are doing this so as to get rid of the denominator. Once each of the terms is free of the denominator, you can easily open the bracket and solve all the terms together. So just multiply it and you will get rid of the denominator. So 2 6 are 12, 3, 4s are 12, 12, 1s are 12. So our equation now becomes 6 into 1, right? 6 into 1 is 6. Yes, Hiba?
Yeah.
6x plus 1 plus 4 into 1 is 4, x minus 1 is equal to 5, x minus 2. Now open the bracket. This becomes what?
I can do this now.
So this will become 6x. I will just give you a short, I'm skipping some steps, so don't think you, how did this come? 4x, then this 5x will come to the other side, will become minus 5x is equal to minus 10 plus 4 plus minus 6. Okay, so this will become 6 plus 4 is 10 minus 5 is 5x is equal to minus 16 plus 4 is minus 8, is it?
Yeah.
Yeah. No, minus 12. Minus 12. So x is equal to minus 12 by 5. Write down this answer so that you can check later on.
Okay.
Okay.
And
Next
the
question.
fourth question.
Fourth question. Okay, this one. See, don't get scared of the decimal points. Again, multiply the entire equation with 10. Why 10? Because each of these has just one decimal place. If one of them was like 1.62, for example, then I would have asked you to multiply the entire equation by 100 so that you can get rid of the denominator entirely. Not denominator, sorry, the decimal point entirely. So multiply it with 10. Multiply
What's the
the
other way
entire.
of solving this question if you're not going to multiply it by 10?
Okay. The other way is x by 1.6 is equal to, take this to the other side, becomes 8.8 minus 2.8, which becomes 6.0. Yes?
Yeah, this one is more easier.
So when you take 1.6 to the other side, x will become 6 multiplied by 1.6. So then you will get your answer.
Okay.
Okay. Then
the 10th one.
10th one is just take this to the other side, because what do we want? We want all the x's to be together as a family and all the constant terms to be together as a family. So here it becomes 5x minus 3 by 2x or 3x
Minus
by
3.
2. 3x by 2 or 3 by 2x, same thing, is equal to minus 14 minus 7 by 2,
Minus
because
7
here
by
it is
2.
plus 7 by 2, so it will become minus 7 by 2. Now you can solve this LCM.
We
Take the
can
LCM of both of these.
write
This becomes,
minus. Yeah.
yes or no? What have we done? We
Yes.
have just solved these two fractions, matlab these two things, taken this denominator as one. And you know how to do this
The
very well. Now
the
this,
the denominator should always be a positive one.
not necessary. But yeah, we try to keep it positive. We try to keep all the negative signs in the numerator because it just helps us in calculation. That's all.
Okay.
Hmm. Okay, then you can solve this.
Yeah.
X will be equal to minus 5. Okay, x will be equal to minus 5. Then next, Do you want to go to the next chapter?
Yeah. Understanding quadrilaterals.
Quadrilaterals. Okay,
The
one sec.
sum of
One sec. Tell me one thing. Out of the chapters that are remaining, understanding quadrilaterals, data handling, squares and square roots, cubes and cube roots. See, comparing quantity is something we have just recently done. Squares and square roots, cubes and cube roots are very simple. Then there's
yeah.
data handling. I think in this question, in this chapter, you have some issue, right? And then there is the quadrilaterals chapter. In that also you have some issue. So I would suggest, Hiba, since we are running out of time, we will do a few questions, but I'm saying one
No,
thing. After this class, please go and practice this chapter very well. Okay. Then tell me what doubts do you have
understanding
from this chapter?
quadrilaterals is not that hard.
No, I know it is not hard, but some questions might be asked which are not directly from your textbook or not directly from the worksheet. So in that you should not get confused. Okay.
Okay.
Now tell which questions do you find a little bit troublesome. We can just discuss those. Also tell me the seventh one. There is a parallelogram. Okay. We know
Okay.
that in a parallelogram, adjacent angles are
Equal 180 degrees. Supplementary.
Supplementary. Now they are supposed to be supplementary. They are saying if the adjacent angles of a parallelogram, there's a particular parallelogram whose adjacent angles are, they are supposed to be
Equal.
supplementary, that they are supplementary also, but more than that, they are equal. Then what is the parallelogram going to be?
It is going to be a rhombus, I think.
Nope.
No. It's going to be a rectangle.
Why is it going to be a rectangle? Because they are saying they are equal as well. So that means if this is x, then this is also x, right? So, and we know that they are adjacent angles also. So adjacent angles are supplementary. That means x plus x is going to give you 180 degrees. That means 2x is going to give you 180. That means x is going to give you 90 degrees. So x is 90, meaning both of these angles are 90. So what happens if both the angles are 90?
They are like in a
See,
rectangle, all the angles are 90 degrees.
so it's going to be a rectangle. Okay.
Okay.
So anything else, Hiba? Because the class time is up. But if there's one question more that you want to ask, we can take that.
The 14th question.